So, let's talk about one of the most critical yet totally invisible systems inside your computer, input/output management. Yeah, I'm talking about everything from saving a file to just moving your mouse. It's this unseen engine that really decides if your PC feels lightning fast or just painfully slow. We're going to pull back the curtain and see exactly how it all works.
I mean, seriously, have you ever stopped to think about it? You've got a huge file downloading, your antivirus is scanning everything in the background, you have a dozen browser tabs open, and you're trying to type an email, all at the same time. Why doesn't the simple act of moving your mouse just stop? Well, the answer is this brilliant system of triage and pure efficiency. Okay, so let's just picture a typical moment on your machine. You've got your foreground tasks, the stuff you're actively doing like browsing or typing, but at the same time, those tasks are competing for resources with a whole bunch of background work. We're talking system maintenance, security scans, file indexing. They all need to read and write to your storage drive, and they all want to do it right now.
And without some kind of manager directing traffic, this would be total chaos, an absolute I/O traffic jam. Every single request would just get in line, first come, first served. That means your simple mouse click could get stuck waiting behind a gigantic chunk of a file download. The whole experience would feel sluggish, unresponsive, and honestly, pretty much unusable. So how does your PC avoid this gridlock?
Well, it all starts with a simple but incredibly powerful idea. Not all I/O requests are created equal. Your operating system basically acts like an expert emergency room doctor, triaging every single request to figure out what's a real emergency and what can wait.
This system is called I/O priority. It's designed to do one thing really well. Make sure that the tasks critical to your experience, the stuff you're doing right now, always get to cut to the front of the line. Meanwhile, all that less urgent background work is told to wait for a quieter moment. It's the secret sauce to keeping your system feeling snappy.
And this priority system has a very clear hierarchy. Right at the very top, you've got critical system tasks, like the memory manager, keeping everything running. Just below that, at high priority, are your direct actions, like typing in a word processor. Then you have your normal foreground apps. And way down at the bottom, that's where you find the background stuff like search indexing, disk defragmenting, and antivirus scans. They are specifically designed to only use resources when it's not going to get in your way.
So you can see this design has two totally different goals. For anything you're actively doing, the system's goal is maximum responsiveness. Your clicks, your keystrokes, they get the VIP treatment, always. But for all that background work, the goal is just efficiency. It uses the hardware when it's idle, but it's programmed to get out of the way the very second you need something. It's a perfect division of labor, really.
And here's where it really hits home. When you're in the middle of an intense gaming session, and all of a sudden a background backup kicks in, I/O priority is the reason you don't even notice. The game's requests are prioritized, while the backup is politely told to wait its turn. But believe it or not, priority is only half the battle.
So, if priority decides what to do first, the next massive challenge is how to process all those requests. It's all about working smarter, not just harder.
See, the old, super inefficient way of doing things is called synchronous I/O. An application would send a request like, hey, save this file, and its worker thread would just stop. It would sit there, completely blocked, doing absolutely nothing until the disk finally confirmed the file was saved. Only then could it move on to its next job. It's an incredible waste of processing power. I mean, that thread could be doing all sorts of other useful work, like keeping the user interface responsive, but instead, it's just stuck waiting. To get around this, modern systems use a much smarter approach.
And that solution is asynchronous I/O. With this model, the application can fire off its request, save this file, and then immediately get back to work. The I/O operation just happens in the background, and the application's thread is totally free to continue processing, rendering graphics, or responding to your clicks. No more blocking. It's a total game changer. Okay, but that raises a really good question. If the application isn't just sitting there waiting, how in the world does it know when the file is actually saved? I mean, it could waste a ton of energy constantly asking, are you done yet? How about now? Are you done yet? There has to be a more elegant way, right?
And of course there is. It's this incredible mechanism called I/O completion ports. The best way to think of it is like a super efficient mailbox. When an asynchronous operation is finally finished, the system doesn't just interrupt the application. No, it just quietly drops a tiny little notification, a completion packet, into this special queue.
And this is what allows for mind-blowing performance. Instead of needing one worker thread for every single task, an application can have a small pool of threads that just sleep until a completion packet shows up.
They only wake up when there is actual completed work to do. This minimizes something called context switching, which is the really costly process of the CPU stopping one task and loading up another. It's the core technology that allows things like web servers to handle thousands of simultaneous connections with incredible efficiency.
Okay, so now we have our two key components, a system for prioritizing what's important and a super efficient way to process the work. Let's see how they combine to create the complete I/O engine.
And that really brings us to the core formula for a responsive system. I/O priority acts as the triage system, deciding what to do first. Then, asynchronous I/O with completion ports acts as the efficient processor, handling all that work with almost zero wasted effort. Together, they transform that potential traffic jam into a free-flowing superhighway.
So, what are the big takeaways here? First, just know that your PC is constantly triaging I/O requests just to protect your user experience. That priority system is what makes your background work never slows you down. And finally, that amazing combination of asynchronous I/O and completion ports is the hyper-efficient engine that processes it all. These two things, working together, are the invisible architects of the smooth, modern computing experience we all just expect.
It really makes you think, doesn't it? Beneath the surface of every single app you use, there are these incredibly clever solutions to really complex problems. What other invisible engines are out there, quietly making our entire digital lives possible? That's a question worth digging into.
If you want to help me out, please smash that like button, leave a random comment, and subscribe if you want to become a better hacker.